All right, so the next topic is called integrals involving integration involving partial fractions. It's a very useful, very good and easy method to integrate something that involves partial fractions. Let me just show you, a simple observation. I just want to begin with this. 3 over x plus 2 minus 2 over, for example, x minus 5. Now, I can do, the common denominator is x plus 2, x minus 5. So I'm just going to put them together. This is just algebra 1, algebra 2 at this point, so nothing special. You're probably smiling and thinking, what does it have to do with calculus? And if you simplify, you get x minus 19 over, that's x squared minus 3x minus 10. Yeah. So this is equivalent to that, right? So nothing special. So now, we're going to go backwards. So we have this part, and we want to express it as the partial fractions. So for example, if they give you integral of x minus 19 over x squared minus 3x minus 10 dx, and they want you to find it, obviously it looks super complicated. So you can actually express it as the difference of two fractions and rewrite your integral as 3 over x plus 2 minus 2 over x minus 5 dx, which is really easy to integrate. Pull out the 3. Now, what's integral of 1 over x plus 2? It's the natural logarithm. It's ln. Don't forget the absolute value, because you don't know what the x values are. X plus 2 minus, pull out the 2, and again ln x minus 5, and then plus the cupcake, and you're done. So the second integrand right here, you see right here, is called a partial fractions decomposition of the first integrand. Okay, and then that's about it. So let me show you the first example. 1 over x squared plus x minus 2 dx. So this is how you start. So here's the method. Standard, you always do this. You say 1 over, factor your denominator, and that's x plus 2, x minus 1. Okay, now split it into two fractions. We don't know what the number on the top is going to be, so we're just going to call it a over x plus 2 plus b over x minus 1. So therefore, and by the way, that equals to 1 over x plus 2, x minus 1. So I can rewrite it like this. 1 equals a x minus 1 plus b x plus 2. It's exactly the same thing. Okay, so then I'm gonna do this. What makes this expression right here 0? X equals 1. What makes this 0? X equals negative 2, right? So then you say let x equal 1. Then you get, so if you plug in 1, so you get 1 equals the 8 times 0 is 0, so it's just b times 1 plus 2 is 3. So in other words, 1 equals 3b, and b equals 1 over 3. Okay, now let x equals negative 2, so then you get 1 equals a times negative 2 minus 1, I'm doing this part right here, is negative 3, plus 0. So therefore, a equals negative 1/3. Done. So now we can put it all together and say this integral I can express as integral of, I'm using this part, a over x plus 2. And what's a? Negative 1/3. X plus 2. So I finished this part. Plus b, and what's b? 1/3 over x minus 1. I did this part. And please don't forget dx because you're integrating. Now pull out negative 1/3. Now what's integral of 1 over x plus 2? It's ln of x plus 2. What's integral of x minus 1? 1 over x minus 1. It's ln of x minus 1 plus, well, it's plus c, right? Now it depends. If it's a multiple choice question, sometimes they play with the answers and they use the properties of logarithms to express as they condense. Sometimes they leave the answers in expanded form. But right now, this is what I got. Okay, the more we practice, the better we get at this. So let me show you the second example. Let's say it says evaluate the following integral, 3x squared minus 7x minus 2 over x cubed minus x dx. So first, I'm going to do a little bit of algebra 2. So I'm just going to say 3x squared minus 7x minus 2 over x cubed minus x equals. I'm going to copy my denominator. I'm going to factor out the x on the bottom. Actually, I can even factor more. So I'm just going to do difference of squares. It's x minus 1, x plus 1, correct? I think so. So now, how many factors do you see? 1, 2, 3. So we're going to have a, b, and c, 3 partial fractions. So they say this is equivalent to a over x, b over x minus 1, and c over x plus 1. Okay? Now I'm going to say 3. I'm doing exactly what I did before, but in my numerator before I had 1. Now I have 3x squared minus 7x minus 2 equals. Now, common denominator is this whole thing, right? So I'm going to multiply this by just x minus 1, x plus 1. And this one I'm multiplying by x and x plus 1. And this one is just x, x minus 1. So that would be a, x minus 1, x plus 1, plus b, x, x plus 1, plus c, x, x minus 1. Okay, now let x equals 0. You see we have, let me do this, 3 factors, 0, 1, and x equals negative 1. So now we're going to plug in. So you say let x equals 0. And then you just plug in 0 for x. Excuse me. You get let me see. 0 minus 1, so it's negative. So that would be 0 times 3 minus 7 times 0 minus 2, so it's just negative 2a. Now 0 minus 1, negative 1, 0 plus 1 is 1, so it's negative 1. And when you plug in 0, that disappears. Okay, so therefore a equals 2. All right, now let x equals, what is it, 1? So same thing. So that would be 3, I'm doing this part right here, 3 minus 7, negative 4 minus 2, negative 6, I believe, equals, if x equals to 1, this part is 0, disappears. Then you get b times 2 plus c times, oh, that's 0, okay, because 1 minus 1 is 0. Okay, so therefore b equals, looks like negative 3. And finally, x equals negative 1. So that would be 3, again that, 3, negative 1, so plus 7 minus 2, and that's 8, equals, x equals negative 1. So negative 1, so that's 0, and you end up with c times negative 1, negative c, negative 1 minus 1, negative 2, so c equals 4. All right, finally, simple math, but takes time. So now we have the 3 separate fractions. Remember, a is 2, b is negative 3, c is 4, and you're going to use these 3 fractions, and you're going to replace a with 2, b is with negative 3, c is with 4. So we're going to say this integral equals to, remember, I'm just going to copy it, 3x squared minus 7x minus 2 over x squared minus x equals integral. So a over x, and a is 2. So it's 2 over x. Then it goes b over x minus 1, but b is negative 3. So I'm just going to put minus and 3 over x minus 1. And then the c is 4 over x plus 1. And the whole thing needs to be, you need to put it in brackets or parentheses because you have dx at the end. So the rest of it is very simple. So integral of 2 over x is just 2 ln of x. Always use absolute value. So 3 absolute value, ln of absolute value of x minus 1 plus 4 ln absolute value of x plus 1 plus c. Finished. So hopefully this makes sense. If you want me to show more examples, please let me know. But otherwise, if you have your homework, please try. And again, you know how to find me. I'm only one WhatsApp message away from you.